for today is about design experiments. So we are going to discuss a little background about design experiments, and the other topic is we're going to discuss the 2K factorial design. So a little bit of background of design of experiments. It is a tool used for improvement, for data gathering, and for data analysis. So here, the design of experiments is used for improvement if we have to investigate something like an output and what are the factors or parameters involved. So a lot of people are doing experiments for that kind of purpose, and I want to discuss first the different types. So here there are three types: best guess approach, OFAT, or one factor at a time, and the other is factorial design. So some people, some engineers or technical people, when they want to improve on something, they just use a best guess approach. And they randomly choose like one or two or some factors, and they do the experiment. So, but that is not kind of validated or systematic or based on both statistical system. So here, OFAT is one factor at a time. There are different factors, and the experimenter will choose only one factor, and all the others are constants. For example, if we take this as an example, if we are going to improve the mileage of a certain car, I may choose only one factor, like tire pressure. So this tire pressure, I'm going to vary like 28 pounds per square inch or 35 pounds per square inch or other pressure, and then I will put all the other factors constant. That's why it's called one factor at a time technique. But the negative or the disadvantage of this is it doesn't consider the interactions between other factors. Because for sure the other factors have also some effect on the mileage or on the output. So we go to the third one, which is factorial design. It is called factorial because we are studying the different factors, what are their levels or what are their settings, and what are their effects on the output. For example, here I have an example of mileage or kilometers. If we want to improve the mileage and we want to investigate on the factors, like it is stipulated here. For example, the factors are tire pressure, gas, oil, type of oil, or the number of hours, and road condition, weather condition, or tire diameter, and so many others. So these are the factors that we want to study so that we will arrive in the best mileage or kilometers. So when we list down the different factors, we are going to screen. So screening means we have to choose what are the critical, what are the factors that really influence the mileage. So if I do the screening, there are different types of screening, like Plackett-Burman or Box-Cox or Taguchi. For example, if I arrive in three factors, then which I consider as critical, so I can concentrate on this and do the experiments. So there are standard methods, or there are different types of design for factorial design. So here is the so-called 2K. Let me explain this. The 2K. This notation. So I may use this red pen. So here is the 2K. 2 is the base which signifies the level, or the setting level. When I say level, it could be low or high or small, medium, like that, level 1 or level 2. So it could be three levels also. For example, small, medium, or high. So those are the levels. Now, what is this K? So this K is the number of factors. So the factors are the parameters that are affecting the output or the variable that we are going to study. So here, the K is the factors. For example, here in my example, we have 3 factors: the tire pressure, type of gas, type of oil. So 2, yeah, 2 to the 3, yeah. So here, if I have 2 to the 3 notations, the question is how many runs are we going to conduct? So here is like exponential, yeah. So 2 times 2 times 2 equals 8. Yeah, so 8 runs. So here, that's why here in this table, I have 8 runs. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Now, for example, if you have 2 factors, yeah, 2 to the 2. Yeah, for example, your factor is only pressure, yeah, or let us say temperature, yeah, for another experiment. If you have 2 factors, how many runs do you have? 2 times 2, so 4 runs. Okay. Now, those number of runs, they are already having the standard design. It was already established long way before, like the one made by Dr. Ronald Fisher. Yeah. So he called this as orthogonal array, or this Latin orthogonal array. Yeah. So here, when you look at the standard statistical tables, they will give you the design. Yeah. For example, the number of factors. If 3, then you have 8 runs. If 2, you have 4 runs. Yeah. So let me discuss the example here. For example, we have 2 to the 3 notation. Yeah. So this one is 2 to the cube, which has an 8 runs, right? So let me explain the factors. I have 3 factors. One is tire pressure. The other is the type of gas. Yeah. And the type of lubricating oil for the engine. For example, if the tire pressure I'm studying a 2 level. Yeah, one is 28 pounds per square inch, the pressure, and the other is 35 pounds per square inch. Yeah, so this one is low level, which is coded as -1, and the other is high level, which is coded as 1 only. Yeah, you can also have low, high, or 1, 2. It depends, yeah, as long as you know what you are talking about in terms of level. So in terms of gas, one, I could use regular for level low level, and high octane gas for the high level. And for the lubricating oil, maybe the brand, yeah, one is provided by Shell, the other is by Caltex. For sure, there are other constant parameters when you are doing the experiments. Yeah, for example, hours. Yeah, I could drive 8 or 10 hours, but here I want to make it constant, so to reduce the variability. For example, here I just want to use 8 hours, or just one whole day, 24 hours. And then we should also make a constant condition for the road. Yeah, I will only use either flat or rough. Yeah, for example, flat road for all the experiments. Yeah, or rough. Yeah, I could not use flat, rough, and other. Yeah, because it will increase the variability. Yeah, the source of errors. Then weather, for example, I will just use sunny. Yeah, or rain. If rainy, all the conditions for experiments are just rainy, or only sunny. Yeah, or if you are in the western or in the US or Canada or Scandinavia, winter. Yeah, and then the tire diameter should be constant. Yeah. So what we are doing this, because these are the factors that we know. So I'll make it constant. Yeah, to reduce the systematic error, yeah, that may be produced. Yeah. So I'll just concentrate here on the 3 factors, like the pressure, the gas, and the type of oil. So here is the standard orthogonal array, which is coded. Yeah. So when you, as I told a while ago, when you look at the standard references, yeah, for any statistical book or the design of experiment reference, so it will give you a standard table. Yeah. So what is this? Is the number of runs, then the factors. Yeah. A, B, C. So for example, here is the A, B, C. Our A is what? The tire pressure. Okay. Then B, what is B? The gas. Yeah. And C is the oil. Yeah. So here, I put it here like coded, yeah. So negative 1, negative 1, negative 1 means here for this first run, all are in the low level. Yeah. So what are those? Negative 1 of A, negative 1 of B, and negative 1 of C is this, right? So I will be using 28 pounds per square inch of tire pressure, then regular gas, yeah, and then the one that is lubricating oil provided by Shell. Yeah, so that is how it is. Yeah. So when I put them in one setup, then I will run, for example, yeah, I may use 8 hours, and then a flat or plain road, only in sunny, or only one tire diameter. Then I will register here the mileage, yeah, because every car, you know, in the panel board, it can register the mileage. Okay. So here next, if we go here, 1, negative 1 means 1 high level of A. So here is A, high level is this, yeah, 35. Yeah? So here is 35, I will put. So here are the coded ones, and at the bottom is the populated parameters. So for example, here, 1 here is 35. You see here is 35 psi, and then negative 1 of B. B, negative 1 is regular, so you can see here. And here, negative 1 of C. Yeah, so here is C, then negative 1 is shell. Yeah, so here is shell. Okay, so this is the translation of the coded parameters. So here, I will use this. Yeah, I'll get the same car that I used in the trial number 1. Then I will put 35 psi in all of the tires. Then I will put regular kerosene, and then lubricating oil is provided by Shell. And all the other constant factors are here. Yeah, so it should be the same. Okay, so same is true with all of this. Yeah, so this. Yeah. So now let me discuss this thing. Why is this like this? Why the Dr. Ronald Fisher and the others have established this. So this is orthogonal. Orthogonal means balance. So why is this balance? If you see the number of the high and low, they are in equal number. For example, here, how many lows do we have? Look at this: 1, 2, 3, 4. Yeah, for all the experiments, yeah, when we are using this factor, yeah, it is 4. For the high is 1, 2, 3, 4. So there's a balance of the number of these factors used. Yeah. So here also, how many negative? 1, 2, 3, 4. Then the positive is this. Yeah. 1, 2, 3, 4. Yeah. And also the same as this. So here is the so-called orthogonal. Now, when we have already this, for example, we were able to get the mileage, yeah, for this, the output. How do we proceed? We can proceed by using these steps. Yeah? So we have to check the data if they are normal. Yeah. So check the data integrity if they are normal. So means if we gather the data, they should resemblance the normal probability curve or the Gaussian curve, meaning the average or a lot of data will fall here on the center, yeah, which is the mode mean, yeah, or median, yeah, and the others are skewed here on the left or right, yeah. So we can use the normal probability plot test and this normal curve, right? And then we have to have some kind of replicates, yeah, to eliminate the variation and to put more integrity to the data. So we can have 1 or 2 replicates. Then when we do the modeling, yeah, for example, modeling, when I say modeling is the output. For example, here the output is mileage, yeah, Y is the mileage, and X are the independent factors or the parameters. Independent factors or parameters. Okay? So here, y equals x1 plus x2 and so on and so forth. Yeah? So there's some modeling to be used, yeah, using the regression, yeah, regression model. So here is the mileage is the so-called dependent, meaning it depends on the factors or the parameters we have cited. Yeah. So here, when we test the regression, we should have this test of line of best fit. Yeah, line of best fit. It should fit the model in the linear. Yeah, so it should be scattered. Yeah, the scatter plot should be near or less error with respect to the linear line. And when we do this regression, there is the parameter called coefficient of linear regression, which is R squared. Yeah, coefficient of determination. It's called coefficient of determination, which the ideal should be greater than 90%. Yeah, to have a best fit. Otherwise, if it's low, so that means your model is maybe inappropriate or incorrect. Yeah? So also the desirability index now. So all these things should be high, yeah, and it should fall under normal probability. So here, after we get the best combination, for example, just for example, experiment number 8 is the best. Yeah. For example, here, if it turns out that it is the best set of parameters that will produce the highest. Yeah. So our objective here, or the sweet spot, is the higher the better. Yeah? For example, higher mileage or kilometers with all this combination of factors. So all this, when we have this, then we can model and then we can confirm. What is the use of confirmation run? Meaning we have to run the trials again, like 2 or 3 times, so that we can be sure that they will produce the same result as before. Yeah, so when we have this combination, they will produce the same mileage. That means it was confirmed that our model is the best one among the 8 runs. So the purpose of confirmation is it should be repeatable and it should be reliable. And after that, then we can confirm with the actual car, yeah, and then we can now suggest to the management or to the group that this is the result of our experiment. Yeah. So I think that's all for it. If I may summarize, this design of experiments we are using is the factorial design because we are analyzing or studying the factors that will affect our output. So here is the configuration 2 to the k. K means the factors and 2 is the level. Yeah. So here, if we have this, there are standard configuration for array, which is found in every references, in statistical references. And all this, if you do the experiments, you have some constants, yeah, to use, so that it will lessen the variability effect or lessen the external systematic external error that may be produced in the experiments. So when we have this, when we run each one, yeah, we can repeat it how many times, but when we run this, we should see the best. Yeah, the best here in this kind of experiment is the highest mileage, or the longest distance it can travel using less fuel. So that's our intentions. And when we have this, the highest mile is produced by which combination? So that combination is the so-called is the product of this orthogonal array. So that is what factorial design is all about. We are studying the different levels of the factors all at the same time, yeah, not one at a time, all at the same time, and then what is the effect in our output, and also their interaction. So there is we can use some statistical software which are standard, like Minitab, yeah, I think now it's 16, and Statistica, yeah, or SAS, JMT, yeah. So these are the standard models because it's hard to do the manual analysis of this, yeah, because there's a lot of data. So all these standard softwares can be used in the analysis of these experiments, like the normal probability plot, the line of best fit, coefficient of determination, or some tests, and also the interaction. Yeah. So if the factors are interacting with each other. So these are coming handy. These softwares are very useful to give you. And also the model, once you do the modeling, it will give you all the necessary products after you get the actual data. So I think that's all for now, and thank you very much.